Welcome to the Slop Farm. Enjoy the video.
You start by verifying prerequisites and taking immediate actions. Check service and application logs for crashes, and read recent GPU driver messages to spot kernel oops. Once done, confirm Python, package locks, and CUDA versus cuDNN compatibility so runtime mismatches won't trigger restarts. Then isolate the model. Run a minimal script using one batch on CPU or apply a 0.5 memory cap to reproduce the fault. This shows whether the issue is resource, dependency, or code related. Once you can reproduce the restart, dig deeper with profiling and targeted fixes. You should run top and NVIDIA SMI continuously, capture trace-malloc snapshots, and correlate peaks with code regions so you know which function leaks memory. Then instrument your training loop with checkpoints, try/accept blocks, and health heartbeats every 30 seconds to prevent abrupt termination. Make sure to test alternatives like smaller batch sizes, mixed precision, or turning off distributed training to see where stability returns and why. You finalize by applying the confirmed fixes, update GPU drivers, pin package versions, add explicit cleanup and safe retries around allocations, because persistent leaks often come from unmanaged resources. Once applied, validate by running full training for 3 to 5 epochs while retaining logs and system metrics to confirm stability. If restarts persist, capture kernel dumps, enable verbose logging, and gather exact reproduction steps so you can escalate. One key troubleshooting tip: always reproduce deterministically before major changes, or you won't know which change helped.
Thanks for watching. Consider subscribing if we helped you today.